least in the fraud group, when we say online, we just mean anything that's not batch. So we have real time with Falcon where, like I mentioned, you're swiping your card and it goes all the way through while you're waiting. We have sort of one behind with Falcon where that transaction isn't, the current transaction isn't used to approve or decline. But it's all queues, sockets, or web services. With app fraud, it's all RESTful web services right now. FICO, well, at least Falcon has SOAP web services, but we're for the new stuff like app fraud, we're doing everything in REST. I have a bunch of slides about REST. I don't know how much time I need to spend talking about REST here. So I'm going to go through this pretty fast, but what we use is Spring MVC. We love Spring in my group, so we're using Spring MVC. So if you guys know REST, we'll skip over all this stuff, but it started run fielding years ago, and it's basically leverage HTTP, right? You got a protocol that's already there, keep the operation, just get put post delete, and then it's all about the data. Leverage the return codes, leverage the headers, etc. And in a sense, why reinvent the wheel there? So, typical thing in our case, we have an application. Obviously, it's application fraud. So, if we are trying to retrieve an application, you might see a REST call like that, and leveraging all the different HTTP codes to decide based on what happened. Were you authorized? Did you not have permission? Couldn't you find it? Things like that.
Did you map put and post to your standard CRUD?
I have a slide on that.
Perfect.
Actually, we skip this one because it's just a little more of the same.
Yeah. Do you find that you get away with just the status code as error messages, or do you have some more detailed error status codes as well?
Yes. It depends on how we're using this and what the data is that we're sending back and forth. Typically, like with our scoring requests with app fraud, the scoring response has an error section in there where we'll put more information. But yeah, the idea is on that first cut, just use the status codes. And in this case, our score response does have a section where we'll put like, more detailed exception message or something like that. So, put versus post, classic REST question. I don't know how many times, every time I go do REST at a new company or new group, I always go back and grab the book. I can never remember what I said last time. So, eventually what I did is I actually went to look at the spec. And so the red stuff, or actually not just the red, but I mean, the two quotes here are directly from the spec. And it's basically put, update, or create, post, create. So, and it all has to do with the URI. So when you do a put, you pass in some ID. That implies that there's some resource there already with that ID. And so obviously you're doing an update. But the spec does say, if the request URI does not point to an existing resource and you're capable of creating a new resource, go ahead and create it. Just make sure that you use 201 rather than 200 if you do a put or you can create an update. And then the post is always to create a new subordinate of the resource. So that's my answer to the put versus post debate. Basically make up your own mind, but be consistent. I think nothing worse than having one of your products doing it one thing and the other way. But from my perspective, based on my interpretation of the spec anyway, that's how I map it. It's hard to do CRUD. It's CRUD. I couldn't even say it, but it would be good. Update and create, not just update. A couple of other gotchas I've seen is just very hard to think about the data first and not just operations. So I'm not going to spend a lot of time here. Classic example is trying to do a bank transfer. And so you say, oh, I'm transferring money from this account to that account. You might do something like account from whatever. But if you think about it, that transfer is itself an object. And if you think of a transfer object as a resource, you could later on, for example, do a get, and somebody could go and get the receipt for that transfer later on. So, and it's still hard for me too, but thinking about what is that data that you're really talking about operating on with only a put post getter delete, it's definitely a challenge. Another thing is search, because the classic thing you'll see obviously is query parameters. That's actually all right. There are problems with that. I mean, you have to figure out, because that's implicitly doing an and of all your things, and you have just one operator, right, which is an equals. So if you wanted to encode something more complicated, you have to figure out how you might do that. And we've come up with ways to specify more complex search criteria when you're doing query parameters. But another thing to think about is actually having a search object. And then, a lot of times you see, I want to save this search, right? And execute that query later. And so you can have that search object, and you create a search, and you'll get an ID back. And if you want to re-execute that search later, you can do that. So you have a search object that you can work with.
I'll just say that dual parameter search is a kind of dangerous since you have a limit on how much you can put in
Sure.
there.
And that's another,
then you end
problem.
up with the get, and then some people implement it in a really weird way where they have a body on the get to get around that.
Well, right, and then how do you have a body on the get, because it's a read, right? And so
Yeah.
then you end up doing a post, and you're coming up with a new operation, which gets back to this thing. But yeah, that's another thing I didn't put down as a limitation, is not only is it just and equals, but you can only put so much on there as well. So search is still an ongoing problem for me with REST, and we use this, not an outbound actually, we don't use that yet, but yeah, if you guys have any better ways to do search. So specifically with Spring MVC, if you haven't used it, obviously provides the model view controller support for building web apps, but obviously, again, since REST is just, the whole point is to use HTTP protocol, you can use everything in Spring MVC to do REST calls, and it's really, as far as the client's concerned, it's all the same, right? Who cares who's making the request? You're saying, I want this at this URL, and I specify what the accept header has. If I want to say one time it's application JSON and another time text HTML, as long as your service, on the other hand, can supply what you want, code doesn't really matter, right? So, I'll show you an example in a second, but if you want to turn on Spring MVC, very simple, go into your web XML and define this dispatcher servlet, which is the front controller that fronts all the actual controllers. And you give it the URL pattern that you want that guy to look on. In this case, because it's our scoring server in this example, and we don't have a UI, it's just scoring requests. It's all about RESTful usage. We're not actually creating any UI out of that. And then just the only other thing that you need to do is have a Spring configuration file. That's your servlet name followed by -servlet. That's the default. You can configure that to be whatever you want as far as what the extension is or no extension. And it's assumed that it's going to be in webinf directory. So in our example here, it'd be webinf scoring servlet XML file. And it's a child of the main application context. Typically what you see above this section is the Spring context listener that loads the web application context and loads all your other Spring configuration. That's created first and set up as a parent context to whatever you put in your scoring server XML in this case. And so you have access to all those beans from your dispatcher server context. So everything's really annotations in Spring, MVC in particular. You could do it without annotations, but it would be ridiculously verbose to try and specify all your controllers. And as you'll see in the code example that I'll show next, it's really tough to do Spring MVC without annotations. So here we are saying don't register all your default controllers because Spring has a set that it'll just go and register to do data conversion for you. In this case, we say we don't care, we just want to have these two. So JAX-P and then JSON. We're using the JAX and JSON implementation for that. So that's how you specify how you want and what you can support as far as the conversion of your web request. So just like you would for any other Spring being that you want to have automatically found, use this add controller annotation, but then you combine it with the request map. So at controller, this tags it as something that will be found automatically when you turn on the class path scanning capability in Spring. But here's the sort of meat of it for REST or, again, it doesn't matter if it's REST or building a web app, but you say, what's your URL? So your request mapping, case history in this case, we're looking up, so in case management, we keep track of everything that happened to that case, and so that's our case history. So looking up by ID, we only, no, I'm sorry, that's not lookup, we're posting it, this is creating a case history. We only support posts, so if you tried to do a get with that stuff, it wouldn't work. The only thing that we're responding with is JSON, one thing we can take is JSON. The at response body basically says that whatever we return from that method goes into the response body, and then as you can see there, we're saying what should be default status code. So the only other thing that's
how do you deal with versioning your path? Do you have?
I have a slide about that.
Nice.
That's the other comment. So hang on to that. So the other thing that Spring MVC is really good at and has an amazing sort of reflection-based way of figuring out what to call is a combination of these annotations and just also looking at what the type of the parameters are. But to start with this example, path variable, this is saying that's what this ID is, and it just does it by name. And then in this case, because for the post, what we're saying is the request body of the post should be converted to a case history object. So that's behind the scenes. Spring's gonna know that, okay, you've got this content, which we said is in JSON, and there better be a way to convert that JSON into this case history. As it turns out, we've annotated the case history with JSON and stuff, so it knows how to do that mapping. But it'll do that for you. I don't have to do anything other than make sure this case history object is annotated appropriately and say that the request body should go into this thing, and Spring behind the scenes just takes care of that before it calls the method for you. The other thing that it'll do is if you want to have access to the servlet request, servlet response, the session, you just put in a parameter there that's type, HTTP session, and it'll pass in the session to you. You don't have to do anything. If you want to have access to the request object, you just say, servlet request, define that variable, and it'll just pass it to you. So you can just set in your method signature and anything that you want there, and as long as Spring is aware of it, it'll just automatically pass that in. And that's all you have to do, in this case, to do a web service that will create a new case history object. Obviously, there's other examples of return and all that stuff, but didn't want to bore you, and I still wanted to show some time. Any questions?
How do you feel this compares with Jersey?
Pretty much the same as I understand it. Joe has more experience with Jersey than I do, but the main reason. What's that?
Do you have any big advantages using Spring? Do you prefer?
I don't know, Joe. You might be able to answer that, but from my perspective, the main reason to use this over Jersey is just we're using Spring everywhere else. So much other of the stuff is Spring based that it's almost like a mismatch. It's mismatched to go with something else. But so as I understand it, it's very similar. Anything to add, Joe?
No, it's very similar, really just Spring's there already for us. We're not using it, so.
So in terms of versioning, I can't claim to have come up with this. Google's my friend just like everybody else's. But you typically see people stick some version thing in the path. If you're a REST purist, that's utterly wrong because you're implying that there's a V1 resource out there that you're adding something to as a child. That said, a lot of people are doing it that way. That's fine, but you know, if you again you're following that pure REST concept, the URI implies resources, and therefore V1 is some resource out there. It isn't. It's just trying to say this is my application version, or you know, my protocol version is version 1. So the approach that we're taking actually just leverages the built-in content negotiation of HTTP. You can specify in your accept header and what version you want, and the server can specify in the content type what stuff it accepts, and you just use straight up content negotiation to agree on what version of the API that you support and what version of the API the server might support, and go from there. So that was all I had about our web services. I'm going to briefly talk about how we're doing more Spring stuff. Surprise, surprise. So Spring Security, originally called a CG, which anybody know, this is a interesting trivia question, but anybody know how they came up with the name CG? When they, AC, every other letter. It's all those. Guy who just used every other letter, first 5 letters, every other letter. So a lot of out-of-box functionality for both authentication and authorization, basic and form authentication, SSO, with another open source project which I'm going to get into, LDAP 5.9, LD pre-authentication, and various kinds of authorization. Roles or groups, basically, as far as Spring Security is concerned, they don't really differentiate. You just sort of set a flag that says, am I considering these groups or am I considering these roles? But fundamentally, Spring Security doesn't really care. And again, just like Spring Bash and all the other Spring stuff, extremely extensible and pluggable. It's based on servlet filters, so you can find a filter chain essentially, and it goes through that filter chain, and it basically applies URL patterns, and I'll show you that example. Turning on Spring Security, just like with, or very similar anyway to the Spring MVC. In this case, you set up a filter and a filter mapping with the pattern. So we're saying here in this case, because this is, again, our scoring server, we're saying everything that you're going through there has to be securitized, authenticated. And like with a lot of other stuff that I was talking about, again, Spring has the concept of a bean DSL or a configuration DSL. In this case, what we did, rather than putting, say, security in front of everything, we set the security namespace as the default and the typical bean namespace as a separate namespace. So all the bean stuff is prefixed by bean or beans, and then all this stuff that's Spring Security specific, we can leave off the namespace definition. So what we've done is they have this thing called HTTP configuration. Autoconfig would basically set up a whole bunch of stuff for you. So turn that off, because all we want to do is basic authentication. And they have the ability to do this expressions, which I'll show you in a second. You can basically define who who has access. So in this case, we're saying there's an API user role, and whoever authenticates better have this authorization. And we don't care what channel in HTTP or HTTPS it comes in on. So if you wanted to, you could say requires channel HTTP, and it would not let you do HTTPS, or you could do HTTPS and it wouldn't let you do HTTP. Or in this case, we don't care. And because we're doing pre-authentication, Spring provides this HTTP 403 entry point, which basically, if you're not pre-authenticated, it's going to go hit this entry point and deny you access. The other thing that we've done to the extensibility point I was making earlier is that we've now said, hey, we want to have a custom filter. So this is the way you would do a custom filter, and you have basically a bunch of different positions that you could put. So they have again, there's this filter chain, and it goes through this series of steps in that chain. And you're basically defining here by saying position where in this chain of filters, and you just have to look at the documentation to see what the order is. And so in this case, we're saying stick this in there just before the authentication filter, so that or just before the pre-auth filter, so that we can do our custom pre-auth filter. And in this case, we basically just implemented a IP whitelist for our authentication here. Before I get into that example, this example is a little more beefy because it's a combination of the form and basic auth. So we're using this to set up the administration console configuration, but the admin server also supports web services. So you have a login using form login, but you're also doing some other fun stuff here, log out and Spring EL. So in that other example where it said access equals and there was a hard-coded string, you could actually put a comma-separated list, but those are hard-coded role names. But by saying use expressions true at the top, you also have the ability to just use Spring EL here, and Spring Security provides a bunch of out-of-box methods. So we're saying all these resources up here are needed just, for example, to be able to show the login page. So whether you're anonymous or authenticated, you have access to all that. But everything else, you need to have HTTPS and you need to be authenticated. Not just basic Spring Security and have to do anything. It just goes through, knows how to do all the redirects and everything. So finally here, some things to point out. Erase credentials. So after you're authenticated, there's an authentication object where it'll maintain whatever credentials you passed in. If you want to have it erase that after you're authenticated, that's all you have to do. And it'll keep the authentication token, but it won't have whatever credentials were passed in. This is how you specify where you get your user information from. So in this case, we have a bean and another file that implements the JDBC loading of user information from the database, which again is something that they provide out of box. You can use that if you want. You can tweak. You can use their JDBC interface, but change the SQL if you have custom SQL that you want to use. Or you can implement your own, or you can use LDAP. There's a lot of pluggable stuff there. The last thing I wanted to mention is just this thing here using Spring Profiles, which they added in Spring 3.1, I think, maybe 3.0. But Spring Security provides this debug configuration, which is extremely helpful when you're trying to figure out what the hell's going on with your authentication and it's not working. It dumps out basically every time that you try and authenticate, it basically dumps out the entire series of steps that it's going through as it goes through all these filters. And so you'll see it's in, I found this user, calling this pre-auth filter, calling this auth filter, calling this, calling that, and then it's, couldn't find the user or credentials bad. And so having that debug information is very helpful, but it dumps out, and it even warns you if you look at the documentation for debug. It says, you know, it's going to print out stuff that you don't want printed out in production. So using the profile mechanism in Spring, you set that so that it's only active in development, and set a different profile variable, or just take this away, production and all that debug stuff. So last slide, I believe, and then I'll hand off to Joe, is just, here's our custom filter that I referenced in the other configuration. So all you have to do is implement the authentication provider. In this case, granted authorities are the permissions that you're giving, the authorization permissions that you're giving. And so in this case, we've hard-coded one, but typically what you would do is you would, you know, once you've authenticated, you'd load all the permissions out of whether it's LDAP or your database and associate those with the authentication token for that user. But in this case, we just have a fixed one. That's because for this, the way that we've done the security for our REST API right now, again, it's just if you're on the IP whitelist, you have access to use the API. And so in this case, we're just giving you that role, assuming that you pass all these authentication checks that we do here as far as the IP whitelist. So there's your authenticate method. That's just right from the interface. And what happens in Spring Security once you get authentication is you have an authentication token that's stuck in a thread local. And so once you're authenticated, you have to return that authentication object. And we have our own class that implements the interface, but they have a lot of ones out of box. And the typical one you would see is a user password authentication token, which is obviously is what would happen, say, if you did a form authentication and you had that user password. Although again, if you set your erase credentials to true, the get credentials wouldn't be there anyway. But they have out-of-box implementations, and we, in this case, provided our own. And it includes whatever the IP addresses that you came in on for access, for logging and debugging. And like most of these filters, it's kind of doing visitor pattern where it's checking whether or not you can, whether this particular filter supports the authentication that we're trying to do here. So if it wouldn't call authenticate, it supports it as well. So just a quick example of doing, again, some customization in Spring. Any questions? Not, Joe, you're up. Let me take my beer.